Introduction. By the end of this lesson, the students will be able to calculate the instantaneous rate of reaction from the concentration time graph and differentiate between initial rate and instantaneous rate. Let us consider the decomposition of N2O5 in CCl4 solution to form O2 gas. Gas is collected in a scaled barometer, and the volume of O2 formed is measured at regular intervals. Click Next to view how the results are represented graphically. Move the slider to view the graph of volume of oxygen produced being plotted against time. What is the average rate of reaction with respect to oxygen during the first 10 seconds of the reaction? Click the average rate button to find out. We can calculate the rate of reaction at a specific time if we use shorter time intervals. This rate is called the instantaneous rate. To calculate the instantaneous rate at t equals 10, click 10. The slope of the tangent to the curve at this point gives the instantaneous rate of reaction. Now click 5, 15, 20 and 25 to view the tangents at different points of the curve. The slope of the tangent becomes smaller and smaller as the reaction proceeds. Discuss and click Next. The rate of reaction decreases with time. This is because the amount of reactants decreases as they are used up during the course of the reaction. Thus, the rate decreases with a decrease in concentration of the reactants. The slope of the tangent at t equals 25 is 0. What can you infer from this? Click Next for the answer. Answer. The reaction has stopped at t is equal to 25 as one or all of the reactants have been used up. The rate of the reaction can also be determined by measuring the change in the concentration of the reactant. Consider the reaction between iodine and propanol. A small sample of reaction mixture is pipetted out at regular intervals into the conical flask containing sodium bicarbonate. What is the function of the sodium bicarbonate? Click Next to know the answer. Answer. The sodium bicarbonate is used to stop the reaction so that there are no further changes to the concentrations of the reactants. The reaction mixture is now titrated against a standard solution of sodium thiosulfate using starch as the indicator. The titer value is recorded. Since the amount of sodium thiosulfate needed is directly proportional to the amount of iodine remaining unreacted, the rate of the reaction can be taken as the change in volume of sodium thiosulfate with time. Click Next to view the graphical representation of the results. Move the slider to obtain the graph. We can now find the rate of reaction at a specific time t. Click T to see how this is done. The rate at a specific instant is called the instantaneous rate. The instantaneous rate can be determined by graphical method. It is taken as the slope of the tangent to the curve at that time. The rate of reaction decreases with time as the reactants are used up and their concentrations decrease. It is not always possible to determine the concentration of a reactant accurately during the course of a reaction. It is preferable to measure the initial rates instead. The initial rate is the rate of the reaction at the start of the experiment, that is, at t=0. Consider the reaction A and B gives C. To find out how the concentration of B affects the rate of the reaction, two experiments are set up using the same volume of A and B but different concentrations of B as shown. Why is the concentration of A kept constant while the concentration of B is doubled? Click Next for the answer. Answer: the concentration of A is kept constant so that any change in the rate of reaction is due to the change in the concentration of B. Click Initial Rate in the table. Compare the values of the initial rate of reaction for both experiments. What is the effect of doubling the concentration of B? Click Next for the answer. Answer: doubling the concentration of B causes the rate of reaction to be doubled. What is the advantage of measuring initial rates of reaction? Discuss and click Next. Answer: the concentrations of the reactants at the start of the reaction are known. We can compare the effects of the concentration of the reactants on the rate of the reaction accurately. The rate of reaction at the start of a reaction t=0 is called the initial rate. It is preferable to measure the initial rate of a reaction as the initial concentrations of the reactants are known.